I'm going to go over some basic concepts that I'm going to use to prepare for the final. And this is going to be the Euclidean algorithm. And how it's linked to linear diophantine equations. Okay. So let me do an example, a really simple example. So if we do the greatest common denominator of 13 and 17, we know it's going to be 1, but if we figure it out this way, I mean, we already know the answer. Then if we invert the relationship and then substitute for 4, this is equal to 4 times 13 minus 3 times 17. This is 52 and this is 51, so that checks. Then we can write the a diophantine equation of the type, and we will know that x0 is equal to 4 and that y0 is equal to minus 3. Okay? So then the equations for x and y are x0 plus b over d, which is 17, and then d is equal to 1 because it's equal to ab. And of course, if we fill in c equals 1, then that's sort of like your base equation. And then y is equal to minus 3 minus a, which is 13. Now, one way to verify, well, the way to verify this is to plug it in. To plug in the equation for x0 and the equation for x, and that equals ax0 plus by0 plus ab over dn minus ab over dn, and these cancel out, and sure enough that equals c. That's just a way to show that. Okay. Then if we want to keep bumping up the c to any other value, especially if we want to get to the point where we have positive values for x and y, just to give you an example, you can do a little table where you say values of x and y, and then, values of a and b. Yeah, no, values of a and b. Values of x and y, I'm sorry. It's x and y. If you do like 1, 0, you're going to get 13. If you do 0, 1, you're going to get 17, and so on. Okay. Now, to get these values, you got to hit a certain n, right, to start getting positive numbers in the x's and the y's. Okay. So, for example, if you want to get positive y's, you're going to have to do, like, let's just say 1. Let's just do 1, for example. What if y is equal to 1? Then negative 13n is equal to 3, n is equal to negative 3 over 13. Of course, n can only be a whole number, and so we're going to have to do it some other way. But I'll give you examples that I plugged in where I got values that were positive. So if you say, for example, n is equal to minus 10, and c is equal to 60, okay, you're going to get x is equal to, so we have to multiply, right, so it's 4, oh, I'm sorry, because we picked 60, we first have to adjust these equations. So these equations become x equals 240 plus 17n, and y is equal to minus 180 minus 13n. And then when you plug in minus 10 in here, you get an x that is equal to 70, right? 240 minus 170 is 70. And then plus 130 minus 180 is minus 50, right? And then when you plug these values in here in this equation, you sure as heck are going to get 60. So 13 times minus 50 is minus 650. Then 17 times minus 50 is minus 850. 13 times 70 is 910. And sure enough, 910 minus 850 is 60. So just to give you an example of the connection between the greatest common denominator, the Euclidean algorithm that you use to find the greatest common denominator, and then the linear diophantine equations. So then what happens, I'm going to do a little example of when the greatest common denominator is not 1. That is somewhere in here. There we go. Yeah. So let's just say that we do 26 and 34, which is really, of course, 13 and 17 multiplied by 2. Okay? So this is going to be 36 is equal to 1 times 26 plus 8. Then 26 is going to be equal to 3 times 8 plus 2. And 8 is going to be equal to 4 times 2. So sure enough, the greatest common denominator is 2. 2 is equal to 26 minus 3 times 8, which is equal to 26 minus 3 times 34 minus 26, which is equal to 4 times 26, which is 104, minus 3 times 34, which is 102. Sure enough, that equals 2. So that checks. And so our, I think I'm going to need a new tripod. Yeah. Sorry, folks. Okay, so that was our equation, right? So this right here is our diophantine equation. Hopefully I will not lose my tripod. So my ax plus by is equal to c here is 26x plus 34y. And then the equations are 4 plus 34 over 2, and never forget the d, right? And then y is minus 3 minus your a divided by 2. So that is 17, and that is 13. And then, of course, you're going to be given this problem a lot, or sometimes, where somebody will tell you, does the equation 26x plus 34y is equal to 197? Does that have solutions? Well, does 2 divide 197? The answer is no, so of course this equation is not going to have solutions. But if somebody gave you an even number, then sure enough, it does have solutions. And how do you find the solutions? Well, you just multiply the factor, right? So 198 divided by 2 is 99, right? So you're going to be multiplying 99 times these numbers to get the new equation. Alright, and I don't know why my tripod keeps doing that, but I'm going to stop right here.